Hello everyone, my name is Ihsan Khairir. I'm a math teacher. I've been a math teacher for about 15 years now. I've been a teacher teaching math in the Malaysian school system, also in international school, teaching IGCSE additional mathematics. I've also taught university, mostly probability and statistics, and I also teach right now A-levels, CIE A-levels. So today I'm going to continue with discussing the solutions to A-levels probability and statistics to paper 9709/63 May June 2025. So I've discussed several of the solutions already. For other questions, we're moving on to question 4 this time. This is a very short question. It's only 4 marks. So let's proceed with discussing it. All right. Emma needs to choose one person at random from 3 people, P, Q, and R. She plans to throw 2 fair coins and note the number n of heads. If n is 0, she will choose P. If n is 1, she will choose Q. If n is 2, she will choose R. So part A question, by considering probabilities, show that the choice made by this method is not random. All right, 2 marks. So the question does say by considering probability, so it is best that we show a probability table for these 3 outcomes, which is choosing P, choosing Q, and choosing R. And since the probability of choosing P, Q, and R is determined by the event of throwing 2 fair coins and noting the number of heads, we should then do a two-way table to count how many number of heads that are possible from the event of or the process of throwing 2 fair coins, right? So here's our two-way table, right? That HT here, this blue one here, is the first coin, and HT here is for the second coin. H means getting a head for the first coin here. The blue T here is for getting a tail for the first coin. This green H here is to get a head for the second coin, and this T here is to get a tail for the second coin. Now, so these are all the possible results, right? So here in this region is when you get 2 heads, both head from the first coin and head in the second coin, so you get 2 heads. This one is when you get the first coin to be a tail, but the second to be a head, so you get 1 head. And this one is you get the first coin to be a head and the second coin to be a tail, so that's also 1 head. And this one is when you get both tails, right, from throwing both coins, and so you get 0 heads. So our values of n are listed here. So in terms of probability, out of these 4 possible outcomes, the probability that P is chosen is when n is 0. So this is 1 out of 4. So we call it 1 out of 4. Q is chosen when n is equal to 1. So there are 2 outcomes of 1 here out of 4. So we call that 2 over 4 or 1 over 2. And for R, she will choose R when n is 2. There's only 1 outcome out of 4, so 1 out of 4. So by considering these probabilities, right, we can see that Q has a higher likelihood to be chosen. Therefore, due to the situation where the events, right, choosing P, choosing Q, and choosing R are not equiprobable, they do not have the same likelihood of being chosen. Therefore, we can say that the choice made by this method is not random, okay? Because again, so we should mention why, right? The choice made by this method is not random because the events P, Q, and R, or the events where Emma chooses P, Emma chooses Q, and Emma chooses R, are not equiprobable. All right, so that is the answer to the first part of this question. All right, now the second part, later Emma has to choose 2 people at random from 3 people. Part B, describe how Emma could use a single throw of a fair six-sided dice to make this random choice. So you want to throw a single fair-sided dice. So just one throw, but you want to choose 2 people. All right, so just look at first, right? Let's consider the situation here. The fair six-sided die has 6 equal probable outcomes. That means the outcomes of the fair six-sided die would be random. All right, so what you can do is, for example, assign different pairs of outcomes to each person. Because it has 6 equally probable outcomes, you take pairs of those outcomes and assign them to each of the persons that you want to choose, because there are 3 people. All right, now this means that each person has an equal 1 in 3 chance of having their number appear on top of the dice when it is thrown. All right, so each of the person, since we assign the pairs of outcomes, right, to each person, that means each person gets 2 numbers. And so all of them will have 2 out of 6 chance, or 1 in 3 chance of having one of their numbers appear on top of the dice when it's thrown. So this is still equiprobable 1 in 3. So throw the dice once, right? So the number that appears on the top of the dice will determine the person who is not chosen. Remember, Emma has to choose 2 people, and we want to throw it only 1 time. Since this is about choosing from 3 people, then the number on the dice, right, will determine the person who is not chosen, because the dice can only show a number for 1 person only, but you want to choose 2 people. Since we have only 3 people, then the dice will determine the person who is not chosen. And so the other 2 people whose numbers did not appear on top of the dice, then Emma can choose those people. All right, so from one single throw of fair six-sided dice, this can now be done. All right, and so that is the solution, right? One of the solutions for this question. I think this one is the most straightforward way of answering this question. Of course, I've left this as a general pair of outcomes here. I didn't mention, hey, first person numbers 1 and 2, second person 3 and 4, third person 5 and 6. It doesn't have to be that, as long as they all have unique pairs of outcomes, right? Unique 2 numbers. They will all have an equal 1 in 3 chance, and therefore will be able to be chosen randomly. Okay, so yeah, so for the 2 marks is for clearly mentioning how you're going to assign the outcomes to the persons and how you're going to make the choice. So in this case, the choice is made by having the result of the dice throw determining who is not chosen. Okay, so that's a very important detail there. All right, so if you do get this answer, right, that means you have done a good job.